say this, Mike, you have come those light years away and just have done so much, okay? You know, it's pretty warm up here. Are you warm? Yeah. I'm a little thirsty, so if you don't mind, can I get a little drink? No. What's that you say? We're in a chemistry situation that we better not drink? Oh. But, well, if you're going to be that way, okay. Wow. I'm relieved, huh? So, let me tell you about myself. As Mike said, I've taught chemistry, but I'm also a professional magician. And so in the magic field, they say, take what you're good at and incorporate it. So I've taken my magic and my chemistry, and I do chemical magic. And so tonight, I'm going to do some of this for you that I presented in many different areas. For some of you non-teachers, there'll be a few moments where I'll explain some of the chemistry, where I'll talk about where I use it in the classroom, but I'll try to minimize that. And I'll be around afterwards if you have any questions. So, I have a philosophy. I give my students CPR. Now let me clarify that before you start figuring something out, okay? I give my students C. What's the C stand for? Chemistry. I make sure they have a rigorous background in chemistry. But that's not the important part. I give them P, the problem solving. And it's all kinds of problem solving. It's the algorithmic mathematical solutions, or it's the thinking part. And that's what I like about my magic aspect, and the students have really seemed to enjoy what I do with the magical aspect. But the R, I think, is the most important. That's the relevance. Not only teaching the chemistry and the problem solving, but you must show the students why you're teaching them. What's the relevance behind what you're teaching? Where can they connect this with their everyday life? So what I've got here is something that is a problem-solving situation. And can some of you figure it out? Uh-oh. It's a trick. It's a double-walled container. It's a glass that has a wall right down between. And what I had on this side is the black scarf, and hopefully you didn't see that. On this side, I had a substance called sodium polyacrylate. So what could you do? You could do this as an introductory lesson for the beginning of the year, just to get some interest, or you could do this when you're talking about hydrogen bonding. You can even take this where you add the salt to it, and it will break some of those hydrogen bonds and make a semi-solution again. But I took this right here and poured it in this end with the sodium polyacrylate, made sure I let it gel, and then, so you saw this, and then what I did is tip it upside down. Now in showmanship, you want that moment to last for just a few seconds so they're starting to think. Were some of you thinking about what's going on? And so then what I did is I took this out and draped my head with it, okay? And now you see something empty, and now you see the whole thing. Now you got to be real careful with this. You've got to make sure that it does gel up. You don't want this being poured. I've seen some teachers where they have a little container on top and they tip it upside down on someone's head and they hope it gels and they pull it out with a little lid and uh-oh. Now also, I'm a deceiving person. This was not Coca-Cola. Why? Because the carbonation, if you would let the carbonation disseminate for a while, it'd be fine, but I just use coffee. And that's all it does, and so you get a good situation there where you can get a nice effect, and now what you've got is an avenue where you can talk about whatever you want to talk about, and that's what I'm going to be doing tonight with some of these effects, giving you avenues where you can present this for your students. Now, another thing you could do is, if you want to get into the heavy-duty chemistry aspect, you could use sodium polyacrylate again. But this is a slight variation. This is called snow powder. And I'm just going to put some in here. And I'm going to take some water. And you can't see it, but you will in a few minutes. Because this is still going to do the gelling. But, oh. That can absorb a certain amount of water, but this does a lot more. And you get kind of like a snow. In fact, you could talk about possibly using this for indoor ski slopes. And once again, show the practicality of something like this. And then once again, you got an avenue where the students really want to pursue more and investigate more. And that's the kind of approach I'm trying to develop in my classroom.